Alright, hey guys, this is section 11.3, geometric sequences and geometric series. So we already talked about arithmetic sequences and arithmetic series, which is when you add the same number each time, or subtract if it's negative, but geometric is when you multiply by the same number each time. So it's the same sort of process if it's recursive, so you're going to have a sub 1 equals a, so that's our first term, and then instead of a common difference, we have what's called a common ratio, which is r. So we're multiplying by the same number each time. We always do it in terms of multiplying rather than dividing. So for example, if we were if we were dividing by 2, we would write that as r equals 1/2 is the same as dividing by 2. So we're always going to write it in terms of a common ratio. We're not going to say divided by 2, we'll say multiplying by 1/2. We're not going to say dividing by 3, we'll say multiplying by 1/3, etc. So let's start with the first one. So show the sequence is geometric, list the first term, the common ratio, and the recursive formula. So this one I can see I'm multiplying by 4 each time. So my common ratio is 4, the first term is 2, and the recursive formula, so a sub n equals 4 times a sub n minus 1. Okay, this one right here, so again, it might be easiest to list out your terms here. So if I plug in 1 for the first term, so that would be 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth. So a sub 1. You can see you're multiplying by 3 each time, so my ratio would be 3. And so a sub n equals 3 times my previous term. So same thing here, it might be easiest to list out your terms. So if I plug in n equals 1, so 3 times 2 is 6. 3 times 2 to the second, 3 times 4 is 12. And then 24, so I can see I'm multiplying by 2 each time, so my first term is 6, my ratio is 2, and a sub n equals 2 times a, that should be, sorry about that, a to the n minus 1. And so those sequences are all geometric. Alright. So then we have the explicit formula, so this is helpful again if you're asked to find something like the 100th term. So that way we don't have to keep multiplying by 2 100 times, for example. So this one again, so we're going to write this as an exponent. So I can see that my r right here is 4. My first term is 2. So then to write this as an explicit formula, it's going to be 2 times 4 to the n minus 1. Okay, and so that will give you, if you, for example, wanted to find the 100th term, you would plug in 100 for n. And we can test this real quick. So let's say I wanted to find the first term, I would plug in 1 for n. 1 minus 1 is 0. Anything to the 0th power is 1. 2 times 1 would give me 2, which is my first term. Okay. Alright, find the 9th term of the geometric sequence. So this is again where it's going to be easiest to write your explicit formula. So a equals 3, r equals, I have to figure out what in the world am I multiplying by each time, and I can see that that is 2/3. So each one is 2/3 of the previous one. So a sub n equals 3 times 2/3 to the n minus 1. Okay, so if I'm finding the 9th term, I'm going to plug in 9 for n. So 3 times 2/3 to the 8, because 9 minus 1 is 8. So you would just plug that in your calculator, and you would get 256 over 2187. Okay, so the recursive formula for the sequence, so we're always going to list the first term. So a equals 3, and then a sub n equals 2/3 times a to the n minus 1, sub n minus 1, sorry. Okay, so to find the sum of a finite geometric sequence, finite meaning it ends, it has an endpoint, it's not infinite. Okay, so finding the first, this is your formula, okay? So A is your first term, R is your common ratio, and N. So find the first sum of the first n terms of the sequence 3 to the n power. So this one is not going to end up being a number because you don't know how many terms. However, you could set this up, and then, for example, if it asks you to find the sum of the first 20 terms, you would have a formula to use. So this is mainly just to practice how to set this up. So first thing I want to do is figure out, well, what would this A be? So 3 to the first equals 3. So A equals 3. Okay. And then I'm just going to plug in the rest. So 3, because that's my A value, times 1 minus, well, what am I multiplying by each time? What is my R value? Well, my R equals 3. Okay. So 1 minus 3 to the n, okay, because that's the first n terms, over 1 minus 3. Okay, and like I said, we're going to be able to simplify this a little bit, but it's obviously not going to equal a number. So 3 times 1 minus 3 to the n over negative 2. So I can simplify this, so negative 3 halves, 1 minus 3 to the n. So there we have kind of a formula here set up so that if I asked you, for example, to find the sum of the first 20 terms, you could use this formula, negative 3 halves, 1 minus 3 to the n, and just plug in 20. All right, use a graphing utility to find the sum of the first 15 terms in the sequence, 1/3 to the n. So we could use that big long formula. Or we know, we learned in the previous unit, or previous section, rather, that we have sigma on our graphing calculator, where we can go n equals 1 to the first 15 terms. That should be 15 up here. Oops, my sigma went away. 15. And then 1/3 to the n. And you could go and write it all out using this formula above, or if you're using a graphing calculator, you could go and just use the sigma notation. When you type that on your calculator, you should get 1/2. Remember how you get that on your calculator is you're going to go to Math, and then you're going to go to 0. And it should be the summation, and then you can just plug it in. And that's back in the previous, I can't remember if it's 11.1 or 11.2, but you can reference those notes there. All right, so what if it's an infinite geometric series? So k equals 1 to infinity, for example. Okay, so it goes on forever. Well, there's actually a really nice formula that we can use to find the sum of an infinite geometric series, and that's a over 1 minus r, where a is our first term and r is our common ratio. So find the sum of the geometric series. So it gives you the first 3 terms. You just have to find a, r, and plug in those numbers. So a, our first term is 1. Well, what am I multiplying by each time? Well, I'm multiplying 1 to 1/3 and 1/3 to 1/9. I'm multiplying by 1/3 each time. So r equals 1/3. Okay? So, and I notice it's plus ... There's no endpoint, so I have to recognize that it's infinite, and that's why I can use this formula. So 1 over 1 minus 1/3. So 1 over 2/3 equals 3/2. So if I add all this up, so really it's 1 1/2, right? So really this is 1, and then if I add up all of these, that will equal 1/2. Okay? So it says initially, now we have a word problem, so something in context, right? Initially, a pendulum swings through an arc of 18 inches. See figure 15. Here's our pendulum. On each successive swing, the length of the arc is 0.98 of the previous length. Okay? What is the length of the arc on the 10th swing? Okay? So this is a geometric problem because it's 0.98 of the previous length. So it's a proportion of the previous length. Okay? So what is the length of the arc on the 10th swing? So I could start with 18 and I can multiply by 0.98 every single time, but it's probably going to be best to write an explicit formula. Okay? So I know I start at 18, okay? And I'm multiplying by 0.98, okay, to the n minus 1. okay? And how I always go back and I kind of check myself. So if I were to plug in 1 to this, 1 minus 1 is 0. Anything to the 0th power is 1. So if I were to plug in 1 on my first swing, I would get 18, okay? So swings through an arc of 18 inches. So the first swing will be 18, and then it'll go down after that, okay? So if I want to find the 10th swing, okay, so then I'm going to plug in 10. So 18, so it's going to be to the 9th power. Okay, so when I get that, I get 15.007 inches. Okay, all right, on which swing is the length of the arc less than 10 inches? Okay, so what I would do, and again, there's many different ways you can approach this, is you have this recursive formula, right? So you can go and put that into y equals in your calculator to the n minus 1. Obviously, it'll turn into x there. So if you go into 18.98 to the x minus 1, and so I'm looking for, if I go to the table, the first place that it is less than 12 inches. Okay, so let's see, 0 and 1. So I can see if I scroll down, and I can also check myself at I can check my other ones, so each one should be, so at 10, if I plug in my 10th swing, I can see at 10 it's 15.007, but I'm looking for the first place that it's less than 12 inches. So I can see at 21, so after the 21st swing, it's 12.017, and after the 22nd swing, it's 11.7766, okay? So that's going to be when it's less than 12 inches. So that's going to be the 22nd swing. Okay. So after 15 swings, what is the total distance? So we need to emphasize here that it's talking about the total distance here that the pendulum will have swung. Okay, so when we're talking about total distance, we're talking about the sum. Okay. So when we're talking about the total distance, we need to find, we're not talking about just 15 swings, we're not just plugging in 15, we're talking about a summation here. And again, there's a couple ways you can do this. You can use that formula, or you can use the summation in your calculator. Okay, so if we wanted to use the formula, it would look like this. So my first term is 18, and then times 1 minus 0.98 to the 15th over 1 minus 0.98. Okay, remember the first 18 represents my first term, the 0.98 represents my r, and then to the n power. When you type that in your calculator, you get 235.288 inches total. Okay. All right, and the last one, when it stops, what is the total distance that the pendulum will have swung? So when it stops, so technically this is an infinite geometric, because it's going to keep going, like when you think about it's going 0.98 every single time. Okay, so it's kind of weird, but if you think like it is going to stop, it's a weird concept, but it is going to stop, but it's going on 0.98 every single time, so it's going to keep going and going and going and going and going. Okay, so the distance, it's an infinite sequence every single time, okay, because it's always 0.98 of the previous length. So even if it's 1 inch, it's 0.98 inches, and then less than that, and less than that, and less than that, and we don't know what that technically is. So therefore, we can use our infinite geometric series, okay? So we're going to use that formula here, okay? So A over 1 minus R, okay? So the total distance that the pendulum has swung. So, 18 over 1 minus r. So 18 over 1 minus 0.98, 18 over 0.02, and it will swing, 900 inches total. Okay. Alright, last page here. Alright, you were interviewing for a job and received 2 offers. $20,000 to start with an annual increase of 6% for the first 5 years, and then $22,000 with an annual increase of 3% for the first 5 years. Which offer is the best if your goal is making as much as possible after 5 years, and then which is the best if your goal is making as much as possible over the contract. So this one is talking about the total, and this one's talking about your salary in year 5. Okay, so they're talking about different things here. Okay, so I'm going to actually make a table here. So we're going to have A and B. Okay, so we start at 20,000. And so year 1 and year 1, you're making 22,000 and you're making 20,000. So that's how much you make for year 1. Okay, so then for year 2, year 3, year 4, and year 5. Year 2, 3, 4, 5. Okay, and so you probably did something similar as far as this math back in Math 1 and Math 3. You don't do it so much in Math 2, but so let's start with just A, 20,000 with an annual increase of 6%. So you'll just multiply by 1.06. Remember, you have to multiply by 1 because that'll keep it the same. So when you do that, you get 21,600. Sorry, not 600, 200. 200. I'm just going to fill in these just for sake of time. 472. 23, 820.32, and 25, 249.54. Okay, so all you're doing there is you're taking it multiplying by 1.06 every single time. Okay, this one you're going to multiply by 1.03 every single time. So this one is times 1.06. So this one is times 1.03 because you're growing by 3% every time. So 22,660, 23,339, 80, 24,039, 99, and 24,761, 19. Okay, so my first question asked me what offers the best if your goal is making as much as possible after 5 years. So that question's pretty easy to answer. I can see that A makes more money after 5 years. Okay. But the second question asks which one makes more money total. So if I were to add up all of these, okay, and if I were to find the total for A and the total for B, which one would make more money? So if I find the total for A, it's 112,741.86, and the total for B is 116,899. So I can see B makes more money total over 5 years. Okay, so you can see that because it starts higher and all these numbers are in general higher than the numbers in A, that although A, the salary is higher after 5 years, B, the total is higher. And that's the difference between a sequence and a series. So this would be the series because that's the sum, and that's just looking at the sequence. All right, last one. So it says the second and eighth terms of a geometric sequence are 3 and 192 respectively. So I'm going to go ahead and 1, 2, 3, 4, 5, 6, 7, 8. 3 and 192. Alright, so I have that. Okay, find the first term, the common ratio, and the explicit rule. So we know it says it's geometric, so we're multiplying by the same number each time. So 1, 2, 3, 4, 5, 6. Alright, so 3 times, so 6 numbers. So first of all, I'm going to divide 192 divided by 3, and I should get 64. So some number multiplied by itself 6 times. So how do I represent that? That's going to be x to the 6th power equals 64. Okay, because it's the same number multiplied by itself every single time. So this seems a little weird, but we're going to take the 6th root of both sides. So when it's arithmetic, you just have to divide by 6, okay, because you're adding the same number. But this time we're taking the 6th root because we're multiplying by that number every single time. So I get x equals 2, okay, because 2 to the 6th equals 64. So I'm going to go ahead and fill in my blanks just to check myself. So 3 times 2 is 6, 12, 24, 48, 96, and 192. Okay, now if I were to go backwards, this would be 1.5. Okay, so the first term is, 1.5. The ratio is 2. And what's asked for explicit rule is 1.5 times 2 to the n minus 1. And that's geometric sequences.